Number 1, name all parallel segments. So the parallel segments are two segments that are facing the same direction, even though they are not the same size. That's okay. We have JL is parallel to NP. We then have MN and LK. And last but not least, we have JK and MP. And for number 2, we see that it says if MP equals 17, so if MP is 17, and then LK is 24. You know what? Let me just attend to that 17. So if MP is 17, before I even look over there, I know that this whole thing from J to K is 2 times 17, which is 34. And then next it says LK is 24. So if that's 24, that means MN has to be 12, because that's going to be divided by 2 since it's getting smaller. And then last but not least, we got, what is it? PN is 13. So PN is 13. We're going to double that or multiply by 2 times 2 for 26. Okay, and now we can go ahead and answer all of these. So JK, if I look over here, is 34. MN is 12. JL is 26. And the perimeter is going to be us adding the 26, the 34, and the 24 on the outside of the triangle. 6, 7, 8, 84. Solve for x. All right, so don't forget we have 2 times the mid segment equals the parallel side. You can use NSolve if you need to. I'm going to subtract 6x from both sides. I get 3x. I'm going to add 14 to both sides. What's the 36? Divide both sides by 3. We get x equals 12. To find DH, same setup. 2 times the shorter parallel line, or the shorter parallel segment. And that's going to equal the larger or longer segment. So we're going to distribute. Again, you can use NSolve if you don't know how to do all this or if you just don't feel like it. Let's see, I'm sorry. I subtracted 10 from both sides, so it gives me 5x. And now I'm going to add 29 to both sides. So it's going to give me 35. Divide both sides by 5. And we get x equals 7. All right, but that's the solution. That's not the final answer. So we need DH. So we're going to take this and we're going to plug in the 7. Let's see, was that 35? 105 minus 29. Ooh, I'm not good at mental math. Hold on, y'all. Alrighty. I'm sorry, and that would be DH. Okay, so that's this line right there. Solving for x again, and we're still dealing with mid segments, so we're gonna see. Oh, wait, this is an angles problem. Okay, so we didn't really go over this. It's not a big deal. I want you to just kind of look. This angle here, right? And this angle here. They are the exact same size. Look, see? They're the exact same size. So this is a part equals part. Don't fret. We're going to subtract 4x from both sides. That's going to be 9x. Going to add 15 to both sides. That's going to be 36. Divide both sides by 9. We get 4. Number 6. So this one, okay, now this one's a little different. I'm sorry. So I'm going to illustrate what's going on here, and hopefully this makes sense. All right, firstly, I just traced those angles so you can actually see what they look like. And I'm going to take this one, and I'm going to, oh, not like that. And I'm going to rotate it And so I think it might work. Okay, so this isn't the best drawing, but you can see here that these angles, they make a line. So when I put them together, they make a straight line, which means they equal 180 degrees. That means they're supplementary. So this is going to be part plus part equals 180. So that's going to be 3x plus 17 equals 8x minus 46. I don't know why I did that. Plus 8x minus 46 equals 180 degrees. All right, and of course you can use n solve, or you can just solve it. So I'm going to combine like terms. So 3 plus 8 is 11. I got to combine like terms with this 17 and this 46. That is not right. I'm sorry. I think it's 29. And it's going to be 180. And then we're going to subtract. Just kidding. Add 29 to both sides. It's going to be... Okay. And then we're going to divide both sides by 11. All right. I really hope that's right. I need a calculator. 11 goes in. I'm sorry. I should just get a calculator. It's going to be 9. Yes. Forgive me. All right. So this x is definitely 19. Okay, number 7. Oh. All right. So we got these two measures, and these are angles. And I'm not even going to worry about this. Don't worry about it. So we're going to move on. Number 8, find SR. Don't forget these are congruent. Part equals part, so. Subtracting 3x from both sides, I get 7x. Adding 3 to both sides, I get 42. Dividing both sides by 7, I get x equals 6. And then we're going to plug it back in for SR. What's that? 18 plus 39. 57 equals SR. Okay, just checking my work, sorry. Number 9. The measure of, okay, so again we have part equals part because these two angles are congruent. So that's going to be 4x plus 2 equals 7x minus 37. We're going to subtract 4x from both sides. We get 3x. Going to add 37 to both sides. That's going to be 39. Divide both sides by 3. That's 13. And we're going to plug this back in to find LMN. So LMN is the whole thing. So we're going to plug it in for both and then add them together. See, so that's 12. I'll do it like this. Okay. 52 plus 2 is 54. All right, so that's this side, 54 degrees. And then we're going to plug it into this one. Okay, yeah, go. Looking good, looking good. All right, and then we're going to add those two together, and that will be 108 degrees. All right, now the fun part, vocabulary. All right, see, we need something that's going to intersect at the circumcenter. Okay, so the 3 line segments that do that are perpendicular bisectors. The in center would be angle bisectors. So angle bisectors go with in center. Centroid, that would be medians. And orthocenters, altitudes. All right, these are circumcenter. All right, so circumcenter means we're talking about perpendicular bisectors. So if you look at your notes, you'll see that. Well, let's plug stuff in first before we start doing that. So SY is 19, and since this is a perpendicular bisector, that means it's cutting that line in half, that line segment. So if that's 19, that means that's 19 over here as well. Let's see, TZ is 21, so TZ is 21. So if that's 21, let me use a different color because it's going to get confusing. So this one is 21, this one is 21, this one is 21. So they're all 21. That's how circumcenters work. They're the same distance from all the vertices. And then ST is 30. ST is 30. Where's ST? Okay, so this whole thing is 30. That means this is 15. And this is 15, right? Because the whole thing is 30. Is that it? Find each measure. All right, cool. Did we do enough? Let's see. SZ. Yeah, it's 21. Already wrote that down on the picture. UY or YU. Okay, right there. It's 19. It's blue. WT is 15. And ZY is right here. Okay, so this one's optional because it's Pythagorean Theorem. So that means it's bonus material. So I'll go over this one time, but that's about it. So if I'm using this triangle, how am I going to do that? This triangle. That's not what I meant to do. Okay, and this is the right angle, of course. So that would be 21, that's 19, and we got to figure out what that is. So we're going to do the Pythagorean Theorem, and since we do know what C is, we're going to subtract. I'm definitely going to leave a calculator for this. Okay, looks like 8.9. Okay. For this one, I'll do it. All right, AG is where? Okay, so this is AG. I'm not writing all that down, so I'm just going to use colors. GC is here. All right, so that's part equals part. And then BC is there. I don't think we're going to need that for this because I'm not doing Pythagorean Theorem on this one, so we'll just stick with the purple and blue because those are part equals part. Lego. So like I said, the purple and blue line segments are part equals part because this one, and this one are all congruent. So that's going to be 6x plus 1 equals 9x minus 11. Subtracting 6x from both sides, and I'm going to add 11 to both sides. We're going to divide both sides by 3. So we get x equals 4. Oh, okay. It says find GF. Okay, I'm going to just stop right there. I know it didn't ask me to find x, but I just wanted to show you guys how to do that. But we're not going to worry about this because we're going to need Pythagorean Theorem, and you're not really being tested on that, so yeah. All right, number 16. V is the incenter. Okay, so incenter means we're dealing with angle bisectors. So keep that in mind. You can use your notes for angle bisectors for this one. QT is 5. So since that's 5, since these are angle bisectors, they're equal on both sides of the angle. So that's also going to be 5. And VU is 7. Okay, so that means, okay, hold on. So this is 7, that means this is 7, and that, so all of those segments are 7. And then PV is 29. Oops, sorry. PV is 29. Okay, I don't think we're going to need this one, but I'm going to write it down anyway. Okay, so let's do the two that we can. SV, we already know is 7. Wrote that down on the picture. QS is 5. We already wrote that down. And we're not going to worry about those in the red box because that's Pythagorean Theorem. Feel free to try it on your own. Excuse me. All right, so number 17, again, we have incenter, which means we're dealing with a angle bisector. So, let's see what we got going on up in here. All right, so this 18x minus 23 is equal to the 7x minus 1 because it's part equals part. Both of these angles are congruent. Subtracting 7x from both sides, I get 11x. Adding 23 to both sides, I get 22. Dividing both sides by 11, I get 2 for x. So we found x, and that's 2. All right, now we need to find the measure of... Okay. I'll do these one at a time. Because, you know what? I'm going to plug it in. I don't care. I'm going to go ahead and plug it back in. So we're going to plug in a 2. We got 18 times 2 minus 23. So that's 36 minus 23. And that's going to be 13. Let's try this one. That's going to be 7 times 2 minus 1, which is 14 minus 1, which is 13. So both of these angles are 13 degrees. I want to write that inside, though, because my brain likes to see it where it's supposed to go. Okay, so that's 13 and 13. Great. Another important tidbit is that this is 47. So that means this is 47. And we can figure out angle G. Do we need to? I don't know. Let's just do it. So this whole thing is 26 degrees. This whole thing at the top was 47 times 94. So that's going to be 94 degrees, because if we add 47 and 47, we should get 94. So to find this angle over here, we're going to do that old trick of 26 plus 94. Add these two together. And then we're going to subtract that from 180, which is obviously 60. And then just divide that by 2. I don't know if we're going to need all this. I'm just doing a lot on the front end, so I don't have to figure it out later, because that whole thing was 60, right? All right, cool. Now let's see if I did too much. The measure of KEJ. So KEJ. KEJ. Oop, already did it. That's 13. Cool. Next we have EFG. So EFG. Did it. That's 94. And we got FGE. So let's see. FGE. That's the whole thing. So we want the 60. And then we got KGJ. KGJ. That's just half this time. So that's the 30. All right. Looks good. Moving right along. Now we're dealing with centroids. So centroid means that these are medians. Since these are medians, that means this is congruent to this. Those are congruent, and these are congruent. That might be important. All right, so let's see. PN is 5. So this is 5 right there. And if that's 5, that means this is 10. Okay, LM is 33. Where's LM? Okay, so this whole thing is 33 now. This whole line segment right there is 33, which means this side is 11 and this side is 22. I got KP is 16. Where's KP? All right, so 16. All right, so this one is 16 between K and P, which means if we divide that by 2, we get 8 on the other side. And then NL is 13. And L is 13. That means KN is 13. All right, let's get into what it's asking us. PM. Okay, so PM is 11. PL is 22. PO is 8. JP is 10. JN. Okay, that's that 10 and that 5. So that's going to be 15 altogether. KL is 13 and 13. So that's 26. All right, none of these are angles. Please don't put degrees. Some of y'all still don't know the difference. The struggle. All right, classify each triangle center. Okay, so this is vocabulary. Ooh. All right, so let me take a look at what we got here. I see that this line is perpendicular, so that's either going to be perpendicular bisector or it's going to be altitude. But I'm looking at it. This is clearly not in the middle of this one, so that's going to have to be altitude. Altitude. Okay, actually, I shouldn't have made that so big because that's not the answer. Put that off to the side. So since that's altitude, they all intersect at the orthocenter. It was asking me for the center. That's why I'm not using altitude. All right, the next one. Let's see what's happening. So we have these line segments, and they are cutting these angles in half. Can you see that they're cutting them in half? Ooh, guess what that is? Angle bisector. Sorry, I'll spell the whole thing. So since it's an angle bisector, that means the center is called the incenter. Whatever. The box is being ridiculous. All right, the next one we look at, we can see, hold on. Okay, that these line segments are cutting the other side in half. So it's a bisector of some sort, or it's going through the midpoint maybe. So let's take another look. Okay, it's not perpendicular. There's no square in the corner, so it's not perpendicular bisector. It's not perpendicular again, so it can't be altitude. It's not cutting the angles in half, so it's not an angle bisector. There's only one left, median. Well, it's not mid-segment, I'm sorry, there's two left. But it's not that, so it's median, which means this is a centroid in the middle. So this middle point is called the centroid. Okay, so that's the centroid. This is the incenter. This is the orthocenter. All right, number next. Oh, just kidding, that's it. We're done.